Imagine you're floating in the dark. Not the dark of a power cut, not the dark of a moonless night, the dark of space, 500 million miles from the nearest human being. Below you, a world the size of our moon glows like a cracked porcelain shell. It's beautiful, hauntingly, impossibly beautiful. And somewhere beneath that frozen surface, something has been alive or waiting for longer than our entire civilization has existed. You don't know what it is. NASA doesn't either. But they're going anyway. From a distance, Europa looks innocent. A pale, blue-white marble, striped with rust-colored lines like veins on the back of a hand. It catches Jupiter's light and reflects it softly, almost gently. If you didn't know better, you'd think it was peaceful. You might even think it was safe. But something is wrong. Those veins aren't decoration. They're fractures. Cracks torn open by gravitational forces, so violent that the entire moon flexes like a squeezed stress ball every single time it orbits Jupiter. The surface isn't solid ground, it's a shell, a frozen ceiling over an ocean that no sunlight has ever touched. Here's the problem. That ocean isn't small. Scientists believe it holds twice as much liquid water as every ocean on Earth combined. And it sits not on top of the moon, but inside it, buried under 15 to 25 miles of solid ice. The pressure down there isn't survivable. It isn't manageable. It would crush a submarine into scrap metal before it reached halfway. You wouldn't even have time to realize what was happening. But it gets worse. The water isn't still. Europa's ocean is heated, not by the sun, which is too far away to matter, but by tidal friction. Jupiter's gravity pulls and stretches the moon's interior constantly, generating heat from the inside out. On Earth, that same process at the ocean floor creates hydrothermal vents, where superheated water erupts from the rock in towers of mineral-rich smoke. And around those vents on Earth, life flourishes. Entire ecosystems in complete darkness, powered not by sunlight, but by chemical energy. The ocean floor of Europa may have the same vents, the same heat, the same conditions, the same possibility. And this is where things change. In 2013, the Hubble Space Telescope detected water vapor erupting from Europa's south pole. Plumes of liquid shooting 120 miles into space. Europa wasn't just sitting quietly. It was venting, exhaling, as if something beneath the surface was breathing. NASA's Galileo probe, which flew past Europa in the late 1990s, found magnetic disturbances that only made sense if there was a massive saltwater ocean churning below. Saltwater, the same kind that fills our oceans, the same kind that birthed our first microbes 4 billion years ago. But that's not even the worst part. We don't know what 4 billion years of isolation does to life. On Earth, life had sunlight, seasons, extinctions, ice ages, constant interruption. Whatever is in Europa's ocean has had none of that. Uninterrupted time. Uninterrupted evolution in the deepest, darkest, most pressurized ocean in the solar system, completely sealed from the universe above it. We have no framework for what that produces. We can't even model it correctly. NASA's Europa Clipper launched in 2024. It's on its way there right now, moving through the void, closing the distance. It will arrive and begin studying that frozen shell, those plumes, that hidden ocean, looking for signs of what's below. And here's the thought that should keep you up at night. We're not sending a message. We're not sending a greeting. We're sending a probe with instruments, scanning, sampling, analyzing, essentially knocking on the ceiling of someone else's ocean. We have no idea what answers back. The universe doesn't owe us a safe discovery. It never has. And Europa has been keeping its secret for 4 billion years. Maybe there's a reason it kept it so well.